Here's an overview of the electrophilic addition reactions for the AQA A-level chemistry. We're going to use ethene as our alkene, although you could look at different alkenes. And we're going to start off with hydrogen bromide as our electrophile. Remember, the electrophile is attracted to the electron-dense carbon-carbon double bond. It has a dipole, so bromine's more electronegative with a delta minus. Hydrogen is therefore delta plus. And our first curly arrow comes from the carbon-carbon double bond to the hydrogen, and the second one breaks the HBr bond, the electrons going on to the bromine. So that first hydrogen's been joined to the first carbon, so the first carbon's got 3 hydrogens attached. The second carbon still only has 2 hydrogens attached, it's got a positive charge, it's a carbocation. And we also form a bromide ion with an electron pair. That electron pair attacks a carbocation, forming a bond to it. So our product is bromoethane. So think about the overall reaction here. We took hydrogen bromide, reacted with an alkene, and we got bromoethane, a haloalkane. In general, hydrogen halides react with alkenes. Alkenes plus hydrogen halides produce haloalkanes. A hydrogen halide is a hydrogen atom joined to a halogen atom, in this case bromine. Let's have a look at what happens if we use a halogen instead of a hydrogen halide. So again, start off with ethene, and we'll now react it with bromine. That electron-dense carbon-carbon double bond induces a dipole on bromine, making that closer bromine very slightly delta plus. Again, the mechanism looks very similar. Curly arrow from the carbon-carbon double bond, break the bromine-bromine bond with a second curly arrow. The first bromine is now joined to that first carbon atom. The second carbon atom still only has 2 hydrogens attached, and it's also got a positive charge. It's a carbocation, and we have the bromide ion with its electron pair, which again forms a covalent bond to that carbon atom, which means we now have 1,2-dibromoethane. So this time, when we take a halogen, for example Br2, and react it with an alkene, it adds to the alkene. So alkene plus halogen goes to give a dihaloalkane. Remember, this particular reaction is a test for double bonds. The yellow-brown bromine water is decolorized by the alkene. The third reaction is between alkenes and sulfuric acid, and it's worth remembering the structure of sulfuric acid. So sulfuric acid has a hydrogen joined to an oxygen joined to a sulfur, which is doubly bonded to 2 other oxygens, which is then joined to another OH. Notice the formula is H2SO4. You should be familiar with that. And the hydrogen atom, which is joined to the oxygen, is delta plus. The oxygen atom is delta minus. So this can act as an electrophile, which will be attracted to the electron-dense carbon-carbon double bond. The mechanism's nice, just the same. There's 2 curly arrows breaking the bonds. So the first carbon atom's now got that hydrogen attached to it. But the second carbon atom still only has 2 hydrogens attached to it, so we've made another carbocation. And in this case, it's a hydrogen sulfate that's our negatively charged ion. It looks exactly the same, except it's lost a hydrogen, and it's got a negative charge on that oxygen. Using the lone pair of electrons, form a bond to the carbocation. There's a curly arrow. And then we stick that hydrogen sulfate onto the carbocation to form ethyl hydrogen sulfate. So in general, when we take sulfuric acid and react it with an alkene, it also adds to the alkene, but in this case it forms an alkyl hydrogen sulfate. Alkene plus sulfuric acid gives alkyl hydrogen sulfate. The way to remember these mechanisms is to look at the similarities between them. They all have certain similarities, and if you can remember those similar features, you'll be able to remember the different mechanisms. It's not 3 separate mechanisms, there's a pattern here. Let's have a look at some of those similarities. The first one is that the first curly arrow always comes from the carbon-carbon double bond to the electrophile, and if it's got a delta plus, it'll go to the delta plus part of it. The second thing that happens is that the bond in the electrophile will be broken. Remember, these curly arrows happen at the same time, so as the first bonds form, the second one breaks simultaneously. The third similarity is that we form a carbocation. So have a look at the carbocations in each case. Each one has a carbon with a positive charge. And notice the anions always attack the carbocation and form a bond to it. So we can see the pattern in each of these mechanisms, and hopefully that will help make your learning a bit easier.